Alright, so today what we're going to be looking at is energy, and starting the unit for energy is standard 7. Looking at energy and energy changes, and seeing about what we have for energy. Because if you think about it, energy is everywhere. When you turn on a light bulb, when you actually move any part of your body, your brain has types of energy going on right now as you think or as I speak. As you hear, there's sound energy. So it's all different types of energy. And what we're going to look at is the types of energy and the way that they change from one form to another. Okay? So the nature of energy, like I said, energy is all around you. I mean, everywhere you look, there's energy around you. You can hear energy as a sound. You can see energy as light. All right? And you can feel energy as wind. And we can harness that wind power with the wind turbines. That's where we get electricity from that. The energy conversion. You use energy when, and just think about this, you hit a softball, you lift your book bag, or compress a spring, any of that kind of stuff, you use some type of energy. And so we use energy every single day. And so what our idea, the main idea behind doing this today is looking at these types of energy and how they are converted from one form to another. Okay? Alright, so nature of energy. Living organisms need energy for growth and movement. Now, in your bodies, you learn in biology, hopefully you learn in biology, that ATP is what your body uses for energy, and it's broken down into ADP, which is adenosine diphosphate. But you'll use that for your energy, and so everything needs energy. Our bodies need energy. We have to eat, every day for energy because our body uses so much energy each day. Now, energy is involved when a bird flies, a bomb explodes, and rain falls from the sky. All that stuff is being energy. Most everything in life is being using some type of energy. Alright, what is energy that it can be involved in so many different activities? So what is energy that it can be involved in so many different activities? Well, when we talk about energy, we have to talk about work, because work is the ability to move an object or the ability to apply energy to the object. So when energy can be defined as the ability to do work. So when you do some type of work, whatever it might be, you're using energy. And if an object or an organism does work, it exerts force over a distance to move an object. Remember last week we talked about this, that the work is being done only if the force applied makes an object move. That's the definition of work. Now the object or organism uses energy when it does that work. Okay? So nature of energy. Because of the direct connection between energy and work, energy is measured in joules, the same unit. So anytime we talk about energy, whether it be work or whether it be the energy of conversions or energy, the mechanical energy, elastic energy, all that kind of stuff, energy is being measured in joules. Okay? So joules is our measurement for energy. Anytime we have energy, it's joules. In addition to using energy to do work, objects gain energy because work is being done on them. When you do work to an object, when you apply that force to an object, that energy is being converted from one energy source to another type of energy source. Okay, so the forms of energy, the main 5 types of energy is, first one's heat energy. We get that from friction, a lot of times from the sun, nuclear energy. Chemical energy, this is a lot of times from food. And fuel also has types of chemical energy. A lot of times it's potential energy. Electromagnetic energy, that's the forms of electrical energy, electricity, and also light energy is involved with that. Nuclear energy what actually is fueling the sun is nuclear energy. Also nuclear fission and nuclear fusion, which gives us a lot of energy. In today's society, when we split atoms or fuse atoms, we get energy from that. And also mechanical energy. That's basically turning kinetic energy into potential energy or potential energy into kinetic energy by some type of movement. Heat energy, like I said, is the internal motion of the atoms. And when the internal motion, when they collide with each other, they produce this heat energy. All right. When the particles move and hit and collide, they produce this heat energy. Heat energy can be produced by friction. When things rub together or hit together, causes friction. It causes things to heat up. Heat energy causes change in the temperature and phase of any form of matter. So solids are really close together, so they're not hitting. They're really tight. They don't move much, so they don't have a lot of friction or not a lot of have particles moving. So there's not a lot of heat energy. Or vice versa, gas is very loose, but they're moving really, really fast, and so it causes a lot of heat energy from those particles colliding with each other. So chemical energy is stored in the bonds of atoms. Any type of bond that's being broken, that chemical energy is then turned into kinetic energy. And when these bonds, like I said, when these bonds are broken, the energy is released. But when it's stored in those bonds, that's chemical potential energy that they'll have inside those bonds. When they're broken and turned into kinetic energy. Also, fuel and food, like I said before, those two things are big chemical energy components. Fuel is in a gas and all that kind of stuff. So it's the energy when it's being broken down or burned, or whatever it might be. It's that energy we get from those things. So that's chemical energy. So is food. Electromagnetic energy is basically two different types. You got the electrical part, power lines, all that stuff, electricity. That's electromagnetic energy, and also our light is also electromagnetic energy, especially Roy G. Biv. You see that in the rainbow, red, orange, yellow, green, blue, violet, and they all represents different forms of electromagnetic energy. Okay. Also, your red Martians invading Venus using the X-ray guns. You remember that analogy from middle school? That's what they said. And all it is these different rays. They have X-rays, radio waves, microwaves, all that kind of gamma rays, all that kind of stuff. So all those are parts of the electromagnetic energy spectrum. Okay, nuclear energy. This is when atoms are breaking apart. When they come together and break apart. Nuclear fission is breaking apart. Nuclear fusion is coming together. When an atom breaks apart, it creates an immense amount of energy being released. And so when that happens, when it's breaking apart, it's called nuclear fission. When it splits, it's called nuclear fission. And when it's coming together, it's called nuclear fusion. A lot of times in our nuclear reactors and stuff, it's nuclear fission going on. When we split an atom, a lot of energy is being released. Also, we get nuclear energy also is powering the sun, and we see that their fossil fuels is that nuclear energy. And also, now right here, this bottom part's not true, but we do live around nuclear power plants in Georgia. We have them, and they're a very, very concentrated form of energy. One split of an atom creates an immense amount of nuclear energy. Okay, mechanical energy is broken down really into potential and kinetic energy. But when work is done to an object, it acquires energy, and this energy acquired is called mechanical energy. So when you kick a football, you give mechanical energy to the football to make it move. So when the transfer of energy from one object to another is called mechanical energy. Okay, bowling a bowling ball, same idea. From your hand to the bowling ball, and that's supposed to be bowling ball right here, but from your hand to the bowling ball to the pins, it's all transfer of energy, whether it be from your kinetic energy from your arms, you can make chemical energy broken down to make it kinetic, the ball hitting the lane, and then the lane hitting the pins, and the pins falling down, making sound energy and kinetic energy as well. So it's a transfer of energy. All right, energy conversion, because that's the main thing we're looking at, energy conversion, and how can energy be changed from one form to another. Because every time you see energy, most of the time it's going on under some type of change. All right, so energy conversion, all forms of energy can be converted into other forms. The sun's energy through solar cells can be converted directly into electricity. Solar panels that we have, we can take the energy from the sun and then turn it into electrical energy. That's conversion. Green plants use the sun's energy, which is electromagnetic, the light energy, and it turns it into chemical energy by putting it into the starches and sugars of the plant through those bonds of the atoms or the molecules. An electric motor, same idea. Takes electromagnetic energy from the electricity in the motor and converts it to mechanical energy. Any motor is moving some type of piston or some type of something is moving it to mechanical energy. So any type of motion is dealt with is mechanical energy. And the battery, same way. Mechanical energy, the waterfall, when the waterfall when the water is falling from the fall, and it turns those turbines like at West Point Dam. Same idea. These water turns these turbines and it causes that mechanical energy to become electrical energy. All right. Same way with a motor. You can read that. Same with the motor. That's the same way from gas to the heat energy from the fire and the piston. The piston moves to mechanical energy, and that actually turns your car. All right. States of energy. The most common energy conversion is really your potential and kinetic energy. Those are the most two common states of energy, and everything else can be broken down from that. Potential energy, key word here is stored energy. Potential energy is stored energy. You can't overcompensate that enough. That's stored energy, okay? And kinetic energy is motion. So potential energy, stored energy, not moving. Kinetic energy is in motion, some type of motion. All right, the energy of motion is called kinetic energy. Like I said, that's the definition. The faster an object moves, the more kinetic energy it has. So the faster it's moving, the more kinetic energy it has. Very simple. The greater the mass of a moving object, the more kinetic energy it has also. So it's also, I think, like the idea of force that we looked at about force equals mass times acceleration. So the greater the mass, the greater the speed, all right, the greater the force. Same idea, the greater the mass, the greater the speed, the greater the kinetic energy. Okay? And it directly depends on mass and velocity. All right, potential energy. Potential energy is the stored energy. Like I said, stored in chemical bonds, fuel, nucleus of an atom, and in foods. Or stored because of the work done on it. Like stretching a rubber band, that's elastic energy. Winding a watch, same idea. Pulling back on a bow and arrow, same idea. And like lifting a brick high up in the air. All right, so even though it's not moving, okay, all right, it has the potential to fall. Same with the waterfall. Same with the stretching the rubber band. When you stretch that rubber band, it has the potential. All right, and it's built up in that rubber band. When you stretch it, has the potential to go somewhere. Once you let it go, it turns from potential energy to kinetic energy. Okay. Like I said, energy that's stored due to being stretched or compressed. That is called the potential energy. Is called elastic potential energy. That elastic word helps you out right there about stretch or compress. Compress like a spring. That's also the same thing as elastic potential energy. Gravitational potential energy basically is this: that the greater you are from land or from the what's this potential energy that is dependent on height is called gravitational potential energy. So basically, the farther you are from the ground, the higher the gravitational potential energy you have. Just say somebody on the first floor has less potential energy, gravitational potential energy than the person on the third floor. Okay, of the school. Just the same way, somebody standing here on the bridge has greater gravitational potential energy than somebody standing here. The higher you go, the more gravitational potential energy you have, because the greater you have of the speed of falling, of the force of falling once you fall that distance. Okay. Same thing with the diving board. 3 meters versus 1 meter. Your 3 meters will have a greater potential energy, gravitational potential energy. All right. Like I said, you ever heard this thing? The bigger they are, the harder they fall. That's really the idea behind it. Gravitational potential energy, the science behind that. All right. So bigger you are, and taller you are, the harder you fall. All right. And you can use this idea about the kinetic versus potential energy conversions in a roller coaster. Think about from start, all right, going up, you're being pulled with that mechanical energy, which is kinetic energy, pulled up to the top of a roller coaster. When you get to the very top, it's pulling up there. Also, you feel like a little stop, all right, and you're sitting there. So that's potential energy. Once you sit there, once you start to go and you're going fast, that turns into kinetic energy conversion. All right, same idea here. All right, the greatest gravitational potential energy is here at the very top. It's not moving yet. And when it starts moving, then gravitational potential energy or just potential energy turns into kinetic energy. Okay. All right, same thing as a basketball throw in your hand. You're gonna have more potential energy here because it's almost like a still moment. All right, so you have the maximum gravitational potential energy or potential energy, and then as it comes back down, you can have the maximum kinetic energy right about here, right before it hits, because it's going the fastest because of acceleration due to gravity. All right. Law of conservation of energy states that energy can either be created or destroyed. Same way law of conservation of matter, same idea, just now it's for energy. Einstein came up with this idea. If energy seems to disappear, then scientists look for it, leading to many important discoveries. So really, energy doesn't disappear, it just becomes unusable. So in 1905, Albert Einstein said that mass and energy cannot be converted into each other. He showed that if matter is destroyed, energy is created, and if energy is destroyed, mass is created. So it's kind of a vice versa kind of deal right there. Okay, that's that famous formula, E equals mc squared. All right, here's your vocab terms for what you need for this unit. We covered all this in the lecture. And there are also some more slides past here that you can look through. But for your lecture and for what you need, this is what it is. Okay, we can stop here. All right, remember, you are smart, you are kind, and you are important. And guys, you have value. Don't let anybody tell you different. Okay. All right, you have a great day. All right, have a great day on purpose.